Okay. So friends, very good morning. In continuation to our earlier classes of AGB 605, we are going to learn something about determinant of matrix. So now you can remember what we have learned in our yesterday's class, isn't it? We have seen the how is the matrix. We have revised actually how to uh, operate the primary operation with a matrix: addition, subtraction, multiplication, and then we have also seen some types of matrix: unique matrix, or scalar and vector kind of matrix, row or column type of matrix, so identity matrix. So we have covered the basic information, revised the basic information regarding matrix. So now the third, or the in this third module, we are going to learn something about the determinant of matrix. So I would like to share the objectives of today's session. First of all, we have to understand the concept of determinant, then how to calculate the determinant with respect to 2 by 2 matrix or 3 by 3 matrix, then what are the properties of determinants, and what are the theorems of determinants. These are key components of our today's lecture. Basically, if we go, yesterday we have seen the matrix is generated or originated in the China in 3rd century, and the determinant, actually it is nothing but a value which is computed from the elements of the matrix. So as an definition, we can say a determinant of a square matrix is a value computed from elements of the matrix by certain rules. Okay, so just what we have to understand, it is nothing but a value, and this determinant of matrix, it is shown with certain denotations. For example, determinants, the abbreviation DT, det, and in bracket A. Matrix, determinant of matrix A has been shown like this: determinant of A, or determinant A, or in simple modulus of A, isn't it? So this is the way to show the matrix. Now we'll see how the matrix has been calculated. So with the help of simple 2 by 2 square matrix, here for example, suppose A matrix is there, and just a while, I am trying to select a big pen so that it will be visible to you. Yeah. So are you able to see this? A is equals to A, B, C, D. For example, these are the 4 numbers, and how we have to calculate the matrix. So the matrix of this A, B, C, D. So we have to consider the diagonal multiplication of diagonal element. For example, in this case, A is to be multiplied with D, the diagonal element, minus this B has to be multiplied with another diagonal element, C. AD minus BC. This is the way to estimate the determinant of a square matrix of order 2 by 2, isn't it? Then for example, here we can see with one example. Here suppose this is one of the matrix 3, minus 11, 7 and 2. These are the 4 elements of this matrix. How we have to estimate the determinant? We are going to multiply this first element 3 with its diagonal element 2. Then we have to minus the multiplication of other elements, minus 11 and 7. So likewise, we are trying to estimate the determinants, isn't it? So this is the case of 2 by 2 matrix. Now, what is the how we are going to estimate the determinant of 3 by 3 matrix? So here we have to consider two concepts. There are two methods actually to estimate the determinant of a 3 by 3 square matrix. So for example, consider this matrix C is there, which is having elements A, B, C, D, E, F, G, H, I. Then here the thumb rule are that consider the first element A. So we are considering the first element. So now here A has to be considered as a multiplication factor for a minor matrix. The minor matrix is that which is a divide of the row and column component of this matrix A. So here, say for example, in this case, if we consider the A, then we have to cull out the elements which are present in the row of A and in the column of A. Are you getting this? So here, the elements in the row are B and C, that we have to ignore. Elements in the column of A, that are D and G, that we have to ignore. And then what is left over? There is a small 2 by 2 matrix consisting of elements E, F, H, and I. Are you getting this? So what we are doing, we are multiplying the factor A, the element A, with its minor matrix. The minor matrix of element A is this E, F, H, I. So likewise, so here what has to be done? First of all, take the first element A, multiply it with its minor matrix. This is nothing but the minor matrix. Then minus or subtract the another component. So this is the B. Then for B, how we will estimate the minor matrix? So consider here again, we have to ignore the elements which are present in the row of B and in the column of B. So in this case, the row elements of B element is A and C, and column elements are E and H. So what is left over? Here D and G, F and I. So we'll form a minor matrix. We'll multiply the B with the other remaining members. Then we have to plus. So we have to plus the third element. For example, C is here. Again, in the same case, we are ignoring the elements in the row and column of C element. So what is left over? The another matrix D, E, G, H. So this is to be considered as a minor matrix of C, and then we have to solve the equation. So here in next slide, we can see with a suitable example. For example, this is a 3 by 3 matrix of one matrix, and for which we have to estimate the determinant. So here what we have to do, we have to consider the first element -5. Then for this -5, we have to consider the minor matrix. So this will be 2, -1, 4, 1. Are you getting this? So what we have to do, we have to multiply the first element with its minor matrix. Its minor matrix will be determinant of these things: 2, -1, 4, and 1. So it is very easy to estimate the determinant of 2 by 2 matrix. Just we have to subtract the multiplication of the diagonal elements. So likewise here we can estimate one component. What we are doing in simple way, friends, we are trying to reach to a one single value which is defining this matrix, isn't it? So determinant is nothing but a single value which is representing or determined by certain rules, certain calculation part from a matrix. So here, if the element is 0, now you can imagine multiplication of 0 with any other minor determinant or any element, it will directly going to give the calculation as a 0. So now another method. So there is another method for estimation of 3 by 3 matrix. It's very simple. What we have to do, for example, for in this case, A is a matrix consisting of elements A, B, C, D, E, F, G, H, I. Then what we have to do, we have to sum up the multiplication of diagonal element. For example, in this case, we have to consider two components, A1 and A2. A1 is the summation of multiplication of those elements which are considered from left to right. Now here you can consider A1 is the summation of A into E into I. So here you can see A into E into I. Then plus B into F into, now what will be here? So you can imaginary, you can consider this column ADG in front of the next. I have shown in the next slide. For example, in this case, 7, minus 10 and 4, this is one of the matrix. What we have to consider? We have to consider this column in front of the matrix. Again, the second in front of this, so that you are able to consider the multiplication of diagonal elements. Are you getting this? So what we are doing, we are multiplying the diagonal elements, we are adding them, and what we are doing, we are subtracting the A2 component, which is received after the summation of multiplication of reverse diagonal multiplication. So here in this example, CEG plus BDI and then A into F and H. So what we are doing, we are nothing but we are placing the columns of the matrix before and after the said matrix, of which we have to determine the determinant, and then we are taking the diagonal multiplication and summation of this diagonal multiplication. Here you can see this is a multiplication of minus 7, minus 9 and 2 is 126. Here 10 into 2 into 7 is minus 140, and 4 into 3 into 1, it is 12. So here this will be the first component, and if we go with this type of multiplication, 2 into 3 into 10, 1 into 2 into minus 7, so these are going to give this component. So after estimating A1 minus A2, we are getting the value of, you can have any one method which we have already seen, the method of this minor matrix, calculation of or multiplication of A1 or this element with their minor matrix, or simply by diagonally crossing. Okay, so here we can estimate. So the next component is the properties of determinant. So I would like to suggest, first of all, try to go through the whatever I have shared with you in the presentation. Then later on, go with the assignment. The assignment is simple, 2 problems I have given. You can find out the determinants of these 2 matrix A. You can estimate this by calculating, and you can verify. I have given you one link to check the solution of determinant of matrix online. You can go through it. And again, I have shown a article, link of the article, where you can find out the reason why we are adding here and why we are subtracting this component. Are you getting this point? So your mind have raised this question. So sir, here for example, A is a plus sign holder, B is also plus sign holder. Still what we are doing, we are subtracting the this component B into this matrix. So to find out that reason why we are showing the indication of plus sign, minus plus, then minus plus minus, then likewise there are certain rules. So for that rule, you will have to go to the or visit to the that article I have shown, and after calculation, then you will be able to understand the properties of determinants. So here let us see the first property of determinant. As you are knowing about the transpose matrix, so here the first property of determinants is that rows and columns can be interchanged without affecting the value of determinant. If you change the row or column interchanging, so you can have the same value of determinant. So for example, here the matrix A means it is indicating the determinant of matrix A is equals to the determinant of transpose matrix. So these are one and the same. Now second, if 2 rows or 2 columns are interchanged, the signs of the determinant is changed. So these are very fantastic properties. You can play with any a single example, and you can verify what this property, whether these properties are correct or not. Just change two rows or two columns, interchange with them, and you can find out the solution or the value of determinant with a altered sign. If it is a if your earlier answer is plus, the next is the minus. So this is very fantastic property. The third property of a determinant, if a row or column is changed by adding to or subtracting from its element the corresponding elements of any other row or column, the determinant remains unaltered. It means that if you are taking, for example, in one column, for example, 10, 20, 30, these are the values. And if you are subtracting a particular number, for example, say for example, 5, or for example, if you are going to add 10 in each value, so no means the value of determinant will be remain same. It will not alter. So this is again a very good property. Then the next property is that if the elements in any row or column have a common factor alpha, we can say constant, then a determinant equals to the determinant of corresponding matrix in which alpha is 1 multiplied by alpha. So you can realize this. For example, say for example, if the matrix is having all the elements which are divided by 2, so here we can say 2 into, we can have a single matrix which will be the showing the constant. So that we can in that way we can find out the value of alpha. For any general matrix, the value of alpha is 1. Now you can understand this property. The next property of determinant is when at least one row of a matrix is a linear combination of other row, the determinant is 0. So in the practical manual, we have given some examples also. And in the next class, we are also dealing with some examples of determination, calculating this determinant. So if we have a row or a column, which is a linear combination of other row or column, so automatically the determinant value will be 0. That we are going to verify in the next class. Then the next property is that determinant of an upper triangular or a lower triangular matrix is the product of main diagonal entry. So if you can realize these properties by considering a standard matrix. So where we are finding out the solution. If we consider the diagonal matrix. So in this case, for example, say for example, this is a diagonal matrix. This is a diagonal element A, E, I. So B, C, F will be the upper diagonal element, and D, G, H will be the lower diagonal elements. So in that case, what the principle or the properties is saying, the determinant of upper triangular or lower triangular matrix is the product of main diagonal entries. So that we can verify. Again, the next property is that the determinant of product of two square matrices is the product of their individual determinant. You can consider two square matrix, and you can take the answer or determinant, multiply that determinant or multiply this two square matrix, you will have same answer. Then the third, last property of determinant is that the determinant of transpose of a matrix is same as that of original matrix. It is very much fact-similar with the very first property we have seen. Row and column can be interchanged. So the same thing has been said in another word, that if we take any matrix and transpose of that matrix, so the determinant will be the same. Determinant is not going to change. Now there are certain important theorems about the determinants. So I have shown just for sake of interest. These things we are going to apply while estimating, or in our next class regarding inverse of matrix, which is quite interesting topic. So for that we'll have to consider these theorems and these properties of a determinant. So here, the important theorems of determinants are like this. If there are two matrices A and B, which are square matrices of the same size, then this thing we have already A into B is equals to determinant A into determinant B. So here what we can say, this thing, this is the property, the determinant of product of two square matrices is the product of individual determinant. So this is the what we can say shown in form of theorem here. Now another thing, if the matrix A or determinant of matrix A be a n by n matrix, then if a row or a column in n by n means any 2 by 2 or 3 by 3 matrix is 0, then determinant of that matrix will be 0. Say for example, if in case of any matrix here, all the elements in particular row or particular column are 0, automatically will have a determinant value as a 0. If one row is proportional to another row, then again also determinant will be 0. If a column is proportional to another column, then also the determinant will be 0. If a column or row is multiplied by with a constant k to result into matrix B, then determinant of B will be the simple multiplication of that constant with the determinant of A matrix. So sorry. So although I know that these are not easy to digest whatever we are discussing, but whenever we are trying to solve with some problems or play with some problems, you can verify these things. So I would like to suggest you, take this example, take these two matrices just for sake of calculation. Go with the finding out the solution for determinant of A, and then go with the before solving, just read out the article which is enclosed as a attachment here. Okay, so you will be able to find out the what are the properties, how the properties are there. Okay, so I think this is a somewhat sufficient for today's. I will hope you will solve the value. You can verify the solutions online also, and you can verify the theorems and properties discussed also. Okay.